it's so weird because they keep doing new releases of OBS where they like change the buttons and stuff, and all that is fine, but it's like guys, your job is to capture the screen, okay? Do a good job at capturing the stream. If there are bad problems like this, like someone doesn't run as administrator, so it's super slow, you have to fix that. It's your program's entire job. Like, what are you doing? Right? And this is the difference. Like, this is the thing that's the difference between open source culture and serious commercial software culture that open source people have never learned. Like, different aspects of that same thing. Like, do a good job at your job, and then you can do fancy extra stuff on top of that, right? If you can't solve it for some reason, if it's an operating system problem that you can't get around, which I doubt, but let's assume it is, then pop up a message that says, hey, bro, we can't go fast until you run as administrator. And that way, if people forget, they will know. And they'll figure out in the first place that their stream sucks for a fixable reason. Like, this is your only job. That's the purpose of this software. Don't make the buttons glossier until you fix that. Oh my God. Could be an edge case. Well, for what percentage of users is it an edge case? Fix it, bro. Okay, so we want to initialize this parameter that we have just added, inflow lateral parameter. What does that do? It, well, so we have this startup pack variable that just when the particle is just being born, we do this. Now, why do we do this? It's because this thing is not actually in charge of spawning. Can I like put default values in GLSL? Probably not. Because we could get rid of this with a Boolean that we set to true. But anyway, the point of this is just to initialize particles in the beginning. Later, when this same shader actually spawns particles, which may not be that far from now, we'll see, then we can just do this initialization at the spawn time, and then we don't have to have weird hacks like this. But it's okay to have weird hacks as long as you know exactly how and when you're going to get rid of them. So that's what we're doing right now is we have weird hacks. It's the same with closed source software. Visual Studio is garbage. Oh, yes, a lot of closed source software is garbage, but I'm talking about something broadly in the culture. There is something broadly in the culture that at least many people in commercial software understand that almost nobody in open source understands. That's what I'm talking about. You think the last few digits were incorrect? It probably is. Like, it's probably the wrong pi. Like, 92653589979. Isn't it 4263? I don't know. We don't, like, it's a float. It doesn't have that much precision anyway. 3238. Okay. How did the wrong pi get in there? I typed it because we don't have a very organized system of includes for these files. Like you can do includes, but because we were doing a lot of experimentation in random, like it's kind of structureless in here. There's a lot of files that, there's way more files than there should be. There's a lot of files that are not used, but we're not investing that much in this because after switching to another rendering API, or maybe during switching to another rendering API, we're probably going to change a lot the way that these things work, because the way this is structured is done mainly to deal with OpenGL, right? So in a different system, we would do something at least moderately different. So, so we're not investing into really even cleaning up the file structure right now, although maybe a little bit of that would be warranted. So, you know, in some files we have a definition for pi, and in some we don't, and I don't even know where it's coming from. It's not coming from globals, clearly. So I just added it. But yeah, later that'll get cleaned up. Yeah, that's somebody else's pi. All right, let's do this. I didn't write that ATN2. Somebody else's. So we're at least going to move mpi up here. And maybe actually, since I did that, we have it now. I mean, you know, it's shaders. Nobody cares. Nobody cares what the size of your pi is in the shaders. Okay. So now we have it. All right, great. So now what? We want to, okay. We want to take our parameter. This is just going to be frac of the flow direction. Now, okay, we're just going to say if in flow, else, all right? And we're going to say do we have a position? Yeah. Okay, so if we're in flow, then we're going to say we want the perpendicular component, or maybe we want the parallel. It doesn't actually matter. We just need a random number between 0 and 1. I don't think we need to map. Actually, we could just pick it totally randomly, can't we? I believe so. Let's just try that. Let's just say, so this is called what? PT state, I guess. All right. It's fracked. It's fracked, people. Okay, so we're not using it yet. So we still have all our, let's reset the level. We still have all our same problems. And what we're trying to do is just make the corners less scrunched. And how do we do that? We do that by the following. We want to, okay. If in flow if we're in flow, we want to take gameplay velocity, but normalize it. And we need to make this. There we go. Okay. Well, we sure messed that up. Oh, implicit cast. Assignment of incompatible types. Oh, how do you... like... Is there a GLSL function? Yeah. Oh, gameplay velocity is... Okay, I see. That's a vec2. So vec3... All right. So that's okay. Now what? If we're not in flow, we make it 0. Okay, so now this still doesn't do anything. We are not using these values. We are not using these values, but we shall. We shall in the following way. Okay. Well, before we do the velocity stuff, so what I want to do, where does the velocity get integrated to position? I guess that happens in the particle thinger. All right. So here's what we want to do. Cornering improvement. If we are in flow and it's a direction different from the one where different from the one we started in, and don't feel the pull direction very strongly until we get close to the lateral parameter. This just works to spread particles out across the turn. All right, I should have done that in an if. So if it's not startup, then we do this. Okay. It's not startup. We're going to do something with the particle state, right? So what is fluid val? That's the fluid sim data map. Okay. So let's just do the if part, and then we'll think about how to make it actually happen. If let's actually do this, but we'll say old velocity is pt state idx dot velocity. Vec to old velocity. Okay, so let's do this condition. If in flow and dot product of normalize gameplay velocity, comma, whoops, I'm putting a parenthesis in the wrong place because we're tired. If that dot product is less than, I don't know, 0.5, right, which is, again, it should really be like 0 or close to 0, but it's fine. So if we get here, we want to say, we want to use that lateral flow parameter. So we need to find out where we are relative to that flow in our current square. So we're going to say vec2 frac xy is frac of position dot xy, right? Okay. So float parallel equals dot product of, okay, we need gameplay dir. Okay, dot product gameplay dir, comma, frac xy. Okay, and then float perp is frac x, normalize frac xy minus parallel times gameplay dir. Okay, so this is a very standard construction. Oh, there's a vec2. Very standard construction. You should know this. If you want to program video games, this is a very common and useful thing, right? Which is, I want to know where am I in this square perpendicularly or orthogonally to some vector, which is the flow direction, right? I want to wait till I cross the flow by a certain amount. Yeah. How do I do that? Nobody cares. Nobody cares about what we're doing. They want to argue about source. That's fine. I started it. I started it, so I get what I deserve in chat. So anyway, nobody cares about the very important math that you should know that's very easy to learn and that everyone can understand. So we're just going to skip explaining it. Anyway, so if I'm even doing it right here. Yeah, okay. So, and actually I don't exactly want to do this construction, honestly. That is not actually what I want to do. I mean, okay. This is something you do once in a utility function. Not true. Not true. So this perp vector here is the vector of this fractional part that is orthogonal to the thinger. What I just realized is this is wrong for two reasons. One, I actually want the length and not the vector. So I could take the length of the vector now, but that's excessively slow. You can use like the Pythagorean identity to get it. But what I also realize is that this has consequences, and I'm not sure what to do about that. So like if we pick 0.99 as our place, we actually can't, we won't see it until we cross over into the flow. So flows near the edge will get less attention, but maybe that's fine because we actually don't want flows near the edge. All right, let's that's fine if it is. So maybe it's fine. We'll observe whether it's fine, and if it's fine, I have an explanation for why it's fine. Where does my knowledge of fluid particle simulation come from? Nowhere. I'm just doing stuff. Like, this is just regular game programming that I'm doing. All right, let's, oh, it's not called dot product. That's what it's called in my CPU code. It's just dot in GLSL. Frac. I keep typing frac. And dot product. Oh my God. Oh my God. Learn to program. Vec3 to Vec2. Gameplay dir. Is gameplay dir? That's a Vec2. Where's the vec3? Let's try it. Normalize gameplay velocity. Okay. Like that? No. Right, because gameplay velocity is 2D. Oh boy. Implicit cast float to bool. Where am I doing that? Am I doing implicit cast to float to bool? Oh, in flow is not a bool. It sounds like a bool. I keep having that same problem. Okay. Vec3 to Vec2. It's in the same line, so it's this one. Gameplay dir. Oh, this is there. All right. So we're back to working. We're still not actually doing anything after all this. Hey man, what's up? The water really ties the room together. Okay. Can't you get the perpendicular part directly by dotting with minus y comma x? Yeah, I mean, you can do that in 2D. It's true. And in fact, there might even be a perp dot function. The thing is, in 3D, there isn't really a way to do that. And we might make this code 3D later, although, you know, I don't know. Okay. So we are gonna now try to use this thing. So here's what we're gonna do is we're gonna say we don't actually want the length. We actually, we just want the vector, the perp. No, we'll do it. This is wasteful. Okay, but that is how far we are in the square, either in the x or y direction, whichever one is perpendicular to where we were. Right? So this is actually what's useful about geometric programming. Like when you start programming games and you're not used to doing this kind of stuff, you might be like, wait, I have to handle the case when the flow goes in X and the other case when the flow goes in Y, and I can't really imagine how to do that except to have if statements about those cases. Oh wait, now we have to handle Z, and your code blows up and it's like discontinuous because of weird things and like I remember having that kind of problem all the time as a beginning programmer, but once you learn these kind of things, you're like, okay, I can do an operation that gives me the result in either case, you know. Now, I'm not saying that I've typed all this correctly so far, but yeah. Okay, now what we're going to say is distance is abs of perp length minus whatever that was called, pt state idx.inflow lateral parameter. Dude, it's so crazy that you can just type this stuff into a shader and it'll work. Like, dude, I remember when shaders were at most 8 assembly looking instructions and it was faking, and it was really the fixed function pipeline. Like, okay. This is wasteful. And then, okay, so we take this distance, and then we're going to say if dist is greater than 0.25, this is a total hack. We'll make this better in a minute. We just want to get it basically working, right? We're just saying you're not allowed to change your velocity if you're in a different flow, but you haven't reached the right point yet. Hey, look, it's already better, kind of. It's actually not totally working, I think. Because what I'm seeing is the corners are a little bit more filled out, but some particles are like not going. Oh, here's what we have to do that I was going to remember to do. So once we decide it's okay to start feeling the pull, set our flow direction now to this new place. Let's actually make this a vec2 because we don't really want it 3D right now. Okay. So it doesn't totally look to me like it's working. And one way to test that is we could just, like, is there any change, right? So we're just going to do this. And I'm going to look at these corners. And I'm going to put an if 0 and not startup. Of course, I wish. Oh, did I? False. All right, false. So this shouldn't do anything. And actually, it looks the same. So we're failing to do something. We're like failing to break our particle or something. Let's it is not quite the same. It's hard to tell, you know. Even if we weren't clearing the particles, it would be hard to tell. It is definitely not working correctly. It's not different enough. Let's put it that way. Let's just do something crazy. Like, if we decide to stop the particle for a little bit, whoops, here, we're going to say that I want to change something permanent about the particle, like the size. Like, do we have a bunch of shrimpy particles? I don't see them. You would see them because they would be pretty high frequency. Let's see. What? We're like not getting here at all. What if I paste this up here? There we go. See, this is never evaluating to true. All right, well, I bet this evaluates to true, right? No, what? Wait, yes? Okay, yes. It is for the people in the river. Ayo, river. All right, so the tiny guys are in the river. That's correct. Now, the big overlapping waves are from guys who are near the river, but big. So they're like overlapping even though their center is off the river. Okay. Make them semi-transparent. Yeah. So it's this part. It's the gameplay dir. Like, we should see little shrimpy dudes when we turn the corner, anytime we turn a corner. What do we use initial desired? That's something we put in last time. I don't remember what that was for. Okay, anyway. Getting all the shaders to work would take way longer. Yeah, I know, man. I know. Boy, wouldn't it be great if I could just step through the shader like I could with any other program and just see what the values of these variables are? Okay, why do we think this is never being true? I would say the reason is I don't know. I would say the reason is I don't know, because it would seem in a failure case, like say for some reason this never got set. Well, it should be 0 probably or something, or like NAND, but then NANDs I think usually compare as false. Maybe GPUs are better about that, I don't know, or worse about that. I don't know. I don't know what to say about this. How would stepping through a shader work? Pick the pixel that you want to step through and step through it. Wait, I saw... Oh, I'm seeing little shrimpy guys. I wasn't looking closely enough. Okay. So we are getting shrimpy guys in the following case. When you started out of flow, so we're getting shrimpy guys here, if you can't see. Twitch may be destroying the compressions, the conniptions. We're getting shrimpy guys. It looks to me like when you spawn a particle outside and then it goes in. Or maybe some of these guys survive from here. But we're not getting them, I don't think, here. Which is, I mean, maybe we are. The shrimpy guy test is not great. I can't tell. We are getting them. Look. Oh my God, I just didn't see because they were like aliasing out because they're too small. Okay, see, the shrimpy guys are stopping. Okay, sometimes it works. But a lot of the time they're just stopping. They're supposed to keep their old velocity. Why are they stopping? But my detection is working. That's good. So let's make the shrimpy guys a little bit less shrimpy. They went to the gym and lifted a little bit. There, yeah, you can see him right there at the corner. See that? That's our guys. Why are they stopping? Old velocity. Do we destroy the velocity in the particle simulate? No, that can't be right. That can't be right. Okay, let's see which of these they are. We're going to take out this shrimp, so now there's no shrimps. I have to keep moving the camera because for some reason every time I Alt-Tab, the game puts the camera back. Oh, see? Like, why? Is it because I hit tab at all? No. It's just when we Alt-Tab, we frickin' put the camera. Why? I don't know. Someone thought that was a good idea. It's driving me nuts. Okay. What was I even thinking before I got annoyed by that? It was... Oh, I want to know which of these. So when we copy to the old velocity, now we're shrimping. And let's see what happens. That's it. So we're supposedly copying these guys to the old velocity. But they're just like chilling. Why? The old velocity should be left to right. So why don't they just keep going left to right? You're legit surprised SF hasn't turned into District 9? Oh, that'll happen by Christmas, man. Switch to prawns. Look at these shrimpy guys. I just want them to shrimp the shrimp. So let's say the theory is that the velocity is getting destroyed by the particle simulator or something. If that's the problem, then we could let them keep going in a different way. We could say that the velocity is equal to the direction, this direction, which we know is the right direction, times, I don't know, 3. I don't frickin' know. Doesn't matter. Okay, I want to see shrimps moving. Shrimps are moving. Look, they're moving. Boom, boom, boom. They're moving so fast, they're like not even getting caught. Okay, let's not shrimp them anymore. And it's going to be times 1. Okay, look, it's sort of working. Like they're pointing the wrong direction, which looks dumb because we did the turning before this, I guess. No, it's after this. Velocity facing stuff. Oh, it turns toward the... let's just set this. Okay. Dear shrimps, how are you doing? Oh, they're not shrimps anymore. Hey, look. Okay, look. Our corners are filling out. I mean, I'm not sure I totally love it, but we've at least filled, okay, we've both filled out, oh God. We've both filled out the corner, and there's less leakage over here. So we're hitting this better, but I can't say I totally love it. But that may be tuning. That may be tuning. Like the thing is, so the problem that I have right now is we actually want them to turn, kinda. Because like the flow in that direction, like in this corner right here, really is south, and it looks east. So the problem is it looks stupid for a particle to be moving sideways. But we can mitigate that by rotating it more slowly. You know, the parameter that we're using to cause it not to feel the force, we can use that to rotate it. And then there's weird, so I don't actually know what's happening down here. Like we see a lot of north-facing particles right here. Like I don't know if that's new. Maybe it's old and like, see, they just keep showing up right there. Maybe it's things that spawn just south of the river. Um, that could be caused by, so right now I have it set up so that even if you're in flow, or if you're born in flow, you don't do that. Like there's just a little bit of weird stuff going on now. Like if you're born in flow, you get the parameter, right, based on where you're born. And if you're not born in flow, you also get a parameter. But that's a little weird. Like I think if you wander from non-flow into flow, we should just turn you and not delay you. Because you don't want particles crossing the river. This thing that we're doing is just for about guys that are in the river. The waves are hard to spot. Yeah. The game isn't done. That's why we're working on it. How about now? Are we there yet? Are we there yet? Are we there yet? Okay. Let's do this. So we have to figure out the old velocity thing. Till we figure that out, we're going to keep this hack. Now, we're going to change our policy. Entering the first flow accidentally, but particle lifetimes should not be that long. We can handle this if we need to. Okay, so inflow lateral parameter. If you're born outside the river, if you don't have the privilege of being in the river, then we okay, so that should maybe be a small improvement in wacky particles. So I want to look for stuff like, do we see wacky particles going north right here? And I haven't actually seen any yet. So I think we did fix that in that way, which is good. Is there deformation on the particles? The wave pattern is dynamically selected based on speed. Like the wave size and curvature is adjusted. I don't think you can really tell that much that that's the case, but it is the case. Okay, so now Now, let's take care of that particle turning. Okay, so we're gonna do let's make it this. What do we call it? We need a better name. Distance to feel the force, right? Okay. We actually, if we're going to gradiate the angle, we might want to do that to the force as well. Let's just say vec2 lerpt dir is mix from from so the inflow direction is our old thing. The new thing is the gameplay velocity pre our weird hack gameplay dir. And what's the parameter? Well, dist divided by, saturate, dist divided by 1 minus distance to feel the force. So like that's the max, right? And then lerpt dir. It's like the derp dir. We broke something. How do you do this in GL? My internet is effing right now. No? So OBS didn't drop frames, but just Firefox wouldn't load pages. So you just go clamp 01. All right, fine. Okay, so that should give it more of a smooth turn, and I believe I see that happening sometimes. You see some weird things, like at the edge here, there's south-facing particles that are going east, which is weird. But you also notice at the corner, it is more like going south, right? And down here, it's more like going west. It's just we have like some west-facing particles that fly off, and they stay facing west. I'm not sure I get that. In fact, they shouldn't be flying off like that. So that's weird. So, well, let's do this. Let's just let them go in the corner, or around the corner, so that we have complete consistency. And so that's still, see, it's cutting the corner a little bit now, but we're just going to tune the parameter a little bit lower. Maybe. One five. I mean, that seems okay. Like the rest of how it's going to look, like it feels a little flat. Like if you look at the one square where the corner is, we kind of have particles bunching up on the lower left, and the upper right is kind of empty. But, and it's a big but, we can always generate particles in a corner if we want to. But also I think we want the corners to maybe look a little more rounded than the blue outline says, maybe. I don't know. So I'm actually kind of okay with this, because before, we can go back and look at what it was like before, and you'll see like the entire right side of this, whoops. God, we've got to fix that too. God damn. The entire right side of this river will be kind of deflated like a flat tire. Right, so if we do this, this is what it was like without our corrections. It's not that bad, actually. Wait, what? Well, you see up here, it's real bad. Down there, it's kind of bad. It doesn't seem as bad as it was before, so I wonder if there's something that we left in that helps? I don't think so. I give up on programming, everybody. I don't know what to do. Float a lily pad for a more final view. Yeah, actually from this angle, for some reason when we were super zoomed in, it was hard to see, but from this angle you can see that this stuff over here to the right of my guy, it's definitely lopsided to the left. Like there are waves on the right, but they're much lower density. So now let's try turning this back on, and hopefully it looks better from here. It does, yeah. Do we have more in terms of like waves escaping? Let me see. So I'm also looking like if you continue the long left-right river to the right, you see some waves between that and then the river that is to the north of the Green Island. But that's true in either case. That's just the fluid sim filling in those squares in between, which we'll figure out what to do about that later. Okay. I think this is a good improvement. There may be bugs in it still. There probably are because it's a shader, but I don't see the bugs right now. There's definitely... If we look in the upper left corner, it almost looks to me like there are particles that never catch and go past it, but I think that's actually the fluid sim making new waves. Is it a really good idea to have absolutely zero syntax highlighting in your editor? Let me see your video game, bro, and then you can tell me how to program. God, people come along here and just say noob stuff like they think I'm just learning how to program. Please, this is annoying. I actually have no idea what that sounds like to people, so if it's really horrible, I apologize. Except to the people who say the stuff that I'm responding to. I don't apologize to those people. Go more ASMR. I don't know what it sounds like, so I cannot go more or less ASMR. I'm going to have to go like watch a VOD at some point to see how bad that is. Sounds like a horribly clipped mic. Yeah, that's what I would expect. Okay, well, you know, that was kind of a minor change, honestly, all things considered, but not too bad still. Let's actually shrimp these guys again. Just because I want to see if any of them are getting away. It looks like some of them are. Yeah, some of them. Okay, no, our function is a little wrong because once you start turning, you should continue turning. And they actually don't. They like start, they go on an angle and then they go. That's weird. Like you should in all cases end up going south. Hmm. It's not just who cares what tools you use, but like someone's going to come on the channel and tell me how to be a successful programmer or something. Like, what? Who is this person? There are definitely people in the world that I will listen to about how to be a successful programmer, but random Twitch chat person who makes a snippy comment about syntax highlighting when they haven't even watched the stream to know enough that every other file type is syntax highlight except for this one. It's like this person has literally seen 5 minutes of the stream or less. Yeah, that's the internet in the year 2020. You don't know why you think I am trying to tell you how to write code. Well, I don't know how else you're supposed to interpret that comment. There are reasons why this particular file is not syntax highlight. But look, if I just go to, for example, here, look, there's syntax highlighting. So gee, maybe there's a pattern or a reason or something. All right. Anyway. So obviously this is not working correctly. Okay. I think my clamp is backwards. So if we're at maximum distance, that's 1 minus this. Like, this is weird, actually, as well. We're going to have to tweak this 1 minus, but... okay. So if we are at distance to start turning, right? We want a function that is 0 at distance to start turning and 1 at 0, right? So if we do this, that is obviously 0 at 0 and 1 at distance to start turning. So we do 1 minus and clamp it, right? So that's 1 at distance to start turning, or sorry, 1 at 0, wait. Yeah, 1 at 0. 0 at distance to start turning. Okay, I claim that's better. Who knows? Well, that is not really better. It might not be the only problem. Like there could be multiple problems. So it's funny. It is filling out that side of the thing more because some of them turn and deflect, but like, all right. All right. So, I mean, what's weird is they just kind of stop turning and go straight. Like, what? A lot of them never turn at all, which means that this number never goes above 0. By much. I don't get it. Let's try turning this up and see if it makes anything more obvious. Not really. I mean, I would say we see more guys deflecting sometimes. Okay, am I doing something conceptually wrong? Like it could be, I'm looking at this stuff, but it could be this stuff that's wrong. Quite likely. I wonder if we can simplify, instead of saying distance to feel the force, we could just say if your coordinate is greater than that. The problem is just you get some particles that overrun if they go up to like 0.9 or whatever. Oh, I've been accused of gatekeeping. Don't worry about that. Not really here, though. Not really here. I've been accused of gatekeeping for saying things like maybe you want to figure out how to program your own stuff over time and not necessarily use Unity forever. Like it's fine to use Unity to get started, but if you want to be advanced, maybe you got to be able to do your own things. or at least your own subsystems. That has had people accuse me of gatekeeping, even though, like, people who are professors at universities accused me of gatekeeping for saying that stuff, and then kind of passive aggressively denied doing it afterward. Like, it's such a poisonous culture, man. I don't even know. Rocket Lab delays launch. Oh, man. What's the mission patch for this one? Because the business time mission patch was pretty good. All right. Collab with XQC and teach him to code. I mean, if he wants to learn, I'm not going to do JavaScript, though. I'm also not going to play Fortnite. I guess that's chess streamers' version of streaming with a celebrity. Like the actual high-end streamers' version of streaming with a celebrity is streaming with like an actual celebrity, right? But low-end streamers' version of streaming with a celebrity is streaming with a high-end streamer. What celebrity inviting me to play Fortnite would convince me to play Fortnite? Nick Cave. If Nick Cave invites me to play Fortnite, then I will. Who else? Elon Musk, I don't know. I would play Apex with Elon Musk, but I don't think I would go to Fortnite. Nick Cage, no. Nick Cave, yes. Nick Cave, I am fairly certain, does not play video games, so I'm safe. But you never know. He might have taken it up. Who else would get me to play Fortnite celebrity-wise? I don't know. Like, I'm not a big celebrity person, like culture paying attention to person. Anyway. Is Nick Cave a celebrity, though? Yes. I mean, compared to who? Is he not a big enough celebrity for you? What if Ken Thompson asked me to go fishing with him? I don't know. I haven't been fishing since I was like a young teenager, so I don't really know how to do it. What if Carmack one day phones, hey, with Romero here, we need a third for Fortnite? That's not going to happen. Romero's in Ireland. Carmack's in Dallas. And I think John C. plays a lot of Beat Saber these days. I don't exactly peg him as a Fortnite guy. Benny Hill. Well, I was avoiding picking people who are no longer with us. Imagine if Benny Hill were actually alive today. At least I'm assuming he's dead. Let me see. He had... Yeah, 92. Wow, he was born in 1924. Benny Hill was in his late teens, early 20s during World War II. That's crazy. It's not that surprising, but okay. George Carlin, yeah. Okay, can I just say, I saw the Bill and Ted 3 trailer, and it looks really bad. I was hoping they were going to make a really good, like, poignant, interesting, deep movie, and it just looks bad. Maybe it's just a bad trailer, but, like, what the hell was that? What the hell was that trailer? It's going to be bad. Like, I mean, Bill and Ted 2 was bad. Yeah, no, the trailer is not good. It is not good. Okay, let's see if we can figure this out before going to bed. Because I would like to be able to check this in working. Fully working. So we're correctly detecting the entry into the crossflow. Because I don't see anyone turning shrimpy in the middle. They all turn shrimpy at the edge, which is correct. That is where you should turn shrimpy if you're going to. Some of them don't need to because some of them are within the range at the side. Okay. Okay, so now it could be that these are the particles that are starting less. But then if they start less, they should get, like, and then accidentally getting kicked out, but they should get their inflow direction set, which should then mean that this dot is greater than, are equal to 0. Next frame. So we shouldn't have a problem, but we could see, we could put the shrimpatizer here, and if shrimped guys are still getting kicked out, they aren't. So all these guys are successfully turning from what I can see. You sort of see them. These are just guys who start in the zone. So they begin turning immediately. Okay. You know, I could probably reformulate this. Let's reformulate this as because having these two parameters is not great. Let's say that this controls, okay, so float magnitude equals so it's going to be this. Same thing. Let's do this. 1 minus clamp, putting the 1 outside. So basically, if we're distance is at 0, like we're right on the parameter we want to be at, magnitude is 1, otherwise it goes down to 0, right? And we're just gonna flatten all this out. So that's the lerpt dir. That's the gameplay velocity, right? This is magnitude. And then this, and then if we get really close, we're just going to set the gameplay dir. We won't shrimp anyone. All right, so broadly speaking, that is not totally failing, although it doesn't look good on the bottom again, so I wonder if I screwed something up. Okay. Let's do a perp dot here. Let's just simplify this stuff. So perp dot is dot so that's the dot with the perpendicular, and then we're going to abs perp dot. I don't think this should be different, but who knows? Doesn't look different. Okay. So now we're going to shrimp some guys down here. These are people who successfully hit the middle of turning. So again, we see those mostly on the left. None of them escape. Oh, that guy got pretty far. Okay, that's kind of interesting that we mostly see them on the left. We should see them on the right as well, actually, if this was working. But we don't. Oh, wait. This is wrong, actually. Because this is going to be between 0 and 0.5. That's what's wrong. Yeah, I got confused. Okay, so we want this to actually be between 0 and 1. We're just going to keep perp dot, right? And we're just going to add 0.5. So actually, so this is between minus 0.5 and plus 0.5. And that puts that in 0 to 1. All right. So we have our param, and then we're just going to go param. Okay, that was incorrect. Okay, I still mostly see shrimps on the left. It doesn't... It's not super encouraging. So the distance is the absolute value of param minus the inflow lateral parameter. Which hopefully is uniformly distributed. Ugh, we can test that later if we get really desperate. I feel like there's still a problem here. Oh wait, this isn't true. This isn't in minus 0.5, 0.5. Right, this is in 0, 1. Theoretically. Okay. Right? Come on, I want to see more shrimps, and I don't. Why do I never see enough shrimps? Okay, right. This should be an abs. I agree. This should actually have an abs. I don't think times 2. The thing is, just depending on gameplay, this could be plus or minus, right? But it's not from the middle. That's what was confusing me before, is I was like thinking about difference from the middle, but that's not what this is. It's just fractional coordinates within the square. So I want to see more shrimps. Maybe I am. Like, oh, there was a shrimp. So the thing is, the shrimps, like, the other thing that happens is the more to the right you are, the more likely they are to die off. So I'm wondering, I don't know, man. Whoa, that guy just shrimped and then escaped really quickly. Like, why do we get sideways flowing dudes? It's because gameplay dir. We don't want to turn toward gameplay dir. We want to turn toward our actual velocity. Like, let's just get rid of this part. And let's just turn toward this. Like, let's just turn to where we're going. That's just what we do. Oh, okay, because, okay. Okay. I mean, yeah, let's just... So if it's startup, we initialize to this. Otherwise, we initialize to just whatever our velocity is. And actually, we could do this. All right, and then if in flow not equal to 0, v is gameplay velocity. Okay, so if we start up and we're in gameplay flow, we pick that. Otherwise, we do the fluid velocity, which is fine. It shouldn't matter either way, honestly, but it is what it is. Actually, no, like, what am I doing? Because we have fluid vel. Fluid vel, yeah, that's what we want to initialize to. Okay. Okay, that's fine. And then down here we say velocity, theta, difference, figure out the wrapping. That's terrible. We're going to have to deal with that at some point. Okay. So now we should always be turning toward our speed, so we shouldn't get this sideways particle just chilling and moving to the side like that. What? Oh, this is if we're in flow. What? Okay, I think this is to prevent weird stuff for small instantaneous velocity changes. Duh. I don't know. It's weird because there are little times when you'll shunt back and forth a lot. And you don't really want the thing to rotate. Maybe maybe I don't know. All right. Did we fix anything else? I kind of don't know, but it's okay. We're making things. We're making things a little bit better in various ways. So the weird thing is I don't see shrimps now. Do I? Oh, yes, I do. Okay, good. I see shrimps. Let's try de-shrimping. See what happens. I don't think it's working very well. And you can't really step through shaders. So, like, what am I supposed to do? It doesn't look like it's working at all now. It's so crazy because this would be so easy just with a regular debugger, and it's just annoying and difficult to figure out what to do here. Sleep can help piece it together. Yeah, that's about where I'm at right now. Is I'm thinking, you know, maybe coming back to it in the morning is the way to hit it. What's the print debugging equivalent of shaders, hard coding colors? Yeah. So normally you can change colors of things and whatever, and I would be tempted to do that, and I may have to resort to that later. The problem is this shader is not even a shader that puts anything on the screen. This is just a so-called compute shader that just fills stuff out that then later some other non-compute shader that does computation can use to draw things. So I could make a debug color parameter in the particle and then set it in here and then draw it in the other thing. It's just hella annoying to do that. But we could do that later. Because I would like to see, for example, I mean, but then it's weird because like you can't actually draw like numbers or anything. So you like make it red depending on what this is. But I kind of want to know both of the target value and the source value. I don't know. There's just not a good way to deal with it, unfortunately. Like debugging some kinds of things in shader land is actually really nice because you visualize something per pixel. If it's something that you can naturally visualize per pixel and it's easy, then it's amazing because you see the whole screen and you're like, oh, I see all the problems. But for this kind of thing, it's horrible and you just wish you could printf a damn number. Like why there isn't printf, I don't know. That's the first thing I would put in my shader language. I think you can jerry-rig some kind of printf actually by now, but I don't exactly know how to do it. Make a smaller map and log to console. Log what text to console, right? Per frame, log dash dash to start the frame, then all the calculated values. Great. How do I log the calculated values? Saw a debugging tool that just emulated GLSL to debug it. Yeah, I mean, I think RenderDoc might do that. I'm not sure if I'm that desperate, but maybe. But yeah, the fact that there's no printf is crazy, right? If there was printf, I could just hard code it to like only printf values in that square, because I can go in the editor and find the coordinates of that square and just type it into the source file and just say, show me what you're doing, right? But I can't do that. Is it possible to perhaps write the binary value into the top n pixels and read them out in your program? We could do something like that. Like this. I mean, we could build a printf system. That's the thing is, you know, the way this particle simulator happens is we map a buffer that it's possible to see from the CPU. It's not a good idea, but we do it right now anyway. But you could, into all your shaders, map a buffer that's like, this is where printf messages go, right? But then you have to like write your printf function in shaderland. And I mean, I can do that. It's just a giant pain in the butt. But we will definitely do that for whatever API that we switch to, if that API doesn't have a shader printf, which I'm not sure if anybody does, honestly. But yeah, like lacking a special print buffer like that, we could like reserve the first particle slot in the particle buffer to somehow contain error information. But then, like I said, a decent amount of the work is like actually figuring out how to write errors to that buffer in a way that's going to be useful. Because you want to just say printf blah, 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 right? Or something close to that. All right, I'm going to go to bed, and we're going to try to figure this out some other time. I think we're pretty close. I think there's just a dumb bug, and I can't see it because we can't debug. There may be multiple dumb bugs. That is the nature of programming sometimes. Okay, we don't need this anymore because we're going toward the velocity. That's how we're turning. Yeah, I don't feel like it's, well, I mean, I don't know. Like, it's weird. Like, it's kind of filled in there. It's just at a different angle, but that's what, I don't know. Let's just see if we switch it to false again, if we can see the difference. I mean, I feel like I see the difference this close. I feel like there's a low density of particles on the right-hand side there. And then down here, I mean, like, for example, right at that bottom corner, you can sort of see that there's pretty much only one particle at a time here. Let's see if that, and of course, the fact that half of this square is filled, right? The one beneath the stones. Half of that square has water. That seems like too much. All right, so we're going to turn it back on and see if any of that changes at all, or if we're sad. Okay, that didn't, no, that did change. Yeah, okay. It's a less intense overlap here. It definitely, you would actually expect the same maximum overlap. It's just on average. I think it's less. I think. I don't know. Down here, that's not really better. Maybe. You know, I can't tell. I can't tell. We actually need some serious diagnostics. I actually do think this is better. I do think it's doing its job to some degree. It's just weird because you have this trick of the light over here where it still looks lopsided. Actually, maybe it is. Like, maybe we're getting more particles, but we still get, it's still unbalanced to a degree, which is why we see one side more. I don't know. Yeah, my internet at home could be having problems. I don't know. Thanks everybody for coming by. We will work more on water in the future, although I may be taking a trip, so we may not stream that much during trip. We'll find out. Thanks everybody, and I'll see you later.